Hello all and welcome. This is Mr. Callan here to help you with another day of learning mathematics. Chapter 4, Lesson 5, Compare Properties of Functions. Firstly, if you had this assignment, go ahead and pause your video, take a look at the answers, check yourself, bring some questions, pause your video, and come on back when you're ready. I will scroll down in a moment. Goal for today, ladies and gentlemen, is to compare and contrast the properties of two linear functions given different representations. Break that down. Compare, contrast, look for similarities and differences. Two different functions and different representations. That means you might be given, say, a table of values and an equation, and you're going to be asking, okay, how are they different with their starting value? What's y-intercept? And how are they different with their slope? Who's going up faster? Who's going up slower? Notes, if you receive notes, is what we're going to start with. Compare functions, compare properties of functions. Let's break this down bit by bit. First and foremost, the most important part, make them the same representation. It might be hard to compare an equation in a table. It might be hard to compare words in a graph. But if you say make them both equations, or make them both graphs, or make them both tables, or make them both into words, if you make them the same representation, it might be easier to compare. Now, some of you are saying, Mr. Cowan, I feel very visual. I'm pretty good with graphs, so I might like to see both on a graph. Other folks might be saying, equations is my game, Mr. Cowan. Equations is my strength. I'm just going to plant the seed. Find your strength. What do you prefer? What helps you the most? But I will challenge you that students with the strongest skills could do both with equations or both with graphs or both with tables or both with words. They can do a number of different representations. Now, other important things for today. Find the starting values. Look for the y-intercepts. And find the rates of change. Find the slope. If, of course, it is constant. If it is nonlinear, you might have a more difficult time comparing something. All right, 2 mistakes you just made. Well, you have not made any mistakes, so instead I will substitute in common mistakes students have made in the past. Number 1, don't forget to really compare. Over and over I hear, well, Mr. Callan got 5 questions a day and Miss Morris got 7 questions a day, and then they stop instead of actually comparing. Therefore, Mr. Callan had less questions per day, or Ms. Morris had more questions per day. So make sure if the question asks you to compare, that you actually compare who's more, who's less, who starts higher, who starts lower. Beware negative starting values. It is possible. Think about owing money, being in debt. Think about swimming underwater. Also, in a table, the starting value should be when 0 is the input, not 1, 0. This is your notes. Make it your notes. Maybe put a circle and draw a line through it. All right. If you wish, pause your video. Put one question down. What is one question you still have about comparing properties of functions? Pause your video. Come on back when you're ready. Just to show you a little example as you are perhaps taking a peek and analyzing this. Some of you, very graphically oriented, but one way or another, you should be able to see Syracuse starts lower, Boise starts higher. You can see it on the table. Boise starts at 50, Syracuse starts at 20. You could see it on the graph. Boise starts at 50, Syracuse starts at 20. Meanwhile, you could also see by looking at the slopes that Syracuse's snowfall increases faster. You can see it on a table. Goes up 16 every 2 weeks. Boise goes up only 5 every 2 weeks. You could see, well, 5 every 2 weeks is 25. 16 every 2 weeks is 8. So you can see it in the equation as well. By the way, Syracuse, New York is generally considered the snowiest city. Certainly not the snowiest place in the United States of America, but the snowiest city in the US. All right, so there's examples, a visual example of how you can compare two functions by either looking at their graphs, by looking at the table of their values, by looking at their equations. And I did not put words on there, but that one will be a possibility as well. Some of you will gravitate toward the verbal. Now, go ahead and flip your book open. Write this down for your homework. Open up to page 317. My homework numbers 9 through 17. Pause the video. Come on back when you're ready. And yes, ladies and gents, I understand number 9 already completed for you, but it's there to help you if it helps. Speaking of help, I'm going to go back a couple pages to page 314 where it says guided practice. And let's go through a few problems. Now, my suggestion, do a problem, pause the video, see if you can start up number 1 on the homework assignment. Do a problem, or some of you like the big picture and you will want to do all the guided practice, follow along with Mr. Callan, and then begin the homework. Do what is best for you. Find your strengths. Let's read number 1. If you'd prefer, you can pause the video and read it on your own. Some folks are auditory, so they prefer to listen. So I'm going to go ahead and read it out loud. Number 1. Tiger in captivity is fed 13.5 pounds of food a day. The graph, meanwhile, shows the pounds of food an elephant in captivity eats per day. Compare the functions, remember to actually compare, by comparing their rates of change. All right, couple things. Firstly, they give us the tiger in words, 13.5 pounds of food each day. They give us the elephant as a graph. But I would recommend to either change both of them to words, both of them to a graph, both to an equation, or both to a table. Lots of folks, lots of my students are big into tables. So notice if I make a table, I'm going to put day in the first column, I'm going to put tiger, and then I'm going to put elephant right next to it. So we have a 3-column table. Some people call it a back-to-back table because you have tiger and elephant right next to each other back-to-back. Tiger, it says 13.5 pounds a day, so we can simply add 13.5 pounds for each one day. That means after the second day, the tiger would be having eaten 27 pounds. Third day is 40 and 5/10 pounds, and so on. Meanwhile, we can then take the ordered pairs from the graph and transfer them to our table. So after day 1, the elephant's eaten 125 pounds. After day 2, 250, and so on. Pretty clear to see just by examining the table, but some folks prefer equations. So let's go ahead and write equations. Now, the only reason I put these subscripts here are so we know the difference between the two. Some people, T for tiger, E for elephant. That's perfectly okay. I wanted to use F for food, so I put food of the tiger. That's what the subscript T is going to stand for. And food for the elephant. Now, tiger, it said 13.5 pounds a day. Meanwhile, nothing with the word says that there was a starting value. And therefore, our equation is going to be the food is equal to 13.5 pounds times D days, plus the 0 if you wish. Elephant, meanwhile, we can see either from the graph, the rise and the run, or from the table, the change in the food compared to the change in the days, that elephant's food increases 125 per day. All right, so problem asked us to compare their rates of change. Elephant eats 125 what? Oh yes, of course, pounds per day. Therefore, it most certainly is the elephant having the greater rate of change. You could say the elephant eats more. You could say the elephant's quantity of food must increase more per day. Let's go on to number 2. I want you to, as we complete number 2, ask yourself, how are number 1 and number 2 similar? How are number 1 and number 2 different? Pause if you want to read it on your own. Otherwise, I will read it out loud. Carol's profit at a craft fair is represented by the function P equals 5 times B subtracting 15, where P is the profit and B is the number of bracelets she sells. Kate's profit is shown in the table. Now, part A says compare the y-intercepts, the rate of change. I put a couple sentence starters there. Part B says how much will each girl make if she sells 30 bracelets? All right, let's just go back and mark up our text, shall we? What do we have here? Carol's profit, and we're given an equation. Kate's profit, shown on the table to the right. I'm wondering at this point which you prefer. Some folks will go right to equations. Other folks, again, a lot of my students like tables. So if I were to just make a back-to-back table, I'll write Kate right here. Should have written that in green. Carol's profit, let's see here. Look at her equation. 5 times 0 is 0, subtract 15 is negative 15. 5 times 1 is 5, subtract 15 is negative 10. 5 times 2, all I'm using is I'm using this equation and substituting in different B bracelets. Some of you may be saying, wait a second, Mr. Cowan, how could she start with a negative number? Well, if she's making bracelets, perhaps she spent $15 just to get the supplies. All right, so now we have a nice back-to-back table with Kate's profits right next to Carol's profits. Some of you might prefer equations. Now, they already gave us Carol's equation, 5 times B bracelets, subtract 15. Let's take a look at the table and take a look at Kate. Kate does appear to go up $5 every bracelet. Okay, but wait a second, Mr. Callan. Does she have a starting value? Does she start in debt, just like Carol did? So what we can do now is we can go back and try to find the 0 point on her table. In other words, instead of going up a bracelet and up $5, go backwards. That would lead us to the point 0, 0. Well, somehow Kate started with 0. Maybe an older brother or sister gave her all the materials she needs. She does not start in debt. So while Carol begins with negative $15, or you could say $15 in debt, Kate begins with nothing, $0. She does not have money, nor does she owe money. Thinking about the constant rate of change, Carol earns $5 per bracelet. Oh, this is interesting. Kate also earns $5 per bracelet. So they have the same constant rate of change. Now let's move that into B. How much will each girl make if they sell 30 bracelets? I'm going to rewrite the equations because you know what? I just don't feel like carrying on this table all the way to 30 bracelets. Could we? Yes. Is it an efficient way? No. What is efficient is saying, okay, what do we know? We know 30 bracelets. Where will that go? Well, that'll go in for the B value. Then we can go ahead and multiply. If I do Kate first, 5 times 30 is 150 plus 0. Well, that's 150. Meanwhile, Carol, 5 times 30 is 150 as well, but don't forget, she started out in debt. So once she pays off her debt, she has $135. Therefore, Carol would earn 135 while Kate would earn 150. So Kate would earn more. Remember, part of our note said if you're asked to compare, compare. I know it doesn't say it out loud in part B like it says it in part A, but it's always a good idea to finish that comparison. As mentioned, think about these two problems. How are they similar? How are they different? Problem 1 has a graph. Speaking of, I could have put the food for the tiger in the graph. 13 and a half, 27, 40 and a half, 54. Boy, oh boy, you can see pretty clearly. But some are not as much of a fan as a graph as a table. We could make tables in both. We could make equations in both. Everyone has different strengths and weaknesses. Life is full of advantages and disadvantages. So analyze what's best for you and then try to attack a weakness. Maybe if you're not so good at equations, you focus on equations a little more. Let's carry on and finish up with number 3, ladies and gents. The cost to rent a raft with 2 different companies is shown. Which company should you use if you want to rent the raft for 9 hours? All right. It looks like we have Water's Edge rafts given in in graphical form, and Ryan's rafts is given as a table. Once again, what you could do is create a back-to-back table. I'm going to make that disappear. Or you could put both on the same graph. But I have to say, something for me that I gravitate towards sometimes are the equations. After all, eventually it's asking us which company do we want for 9 hours, and 9 is off the graph and it is way off the table. So let's see if those equations help us. Now let's start with Water's Edge rafts. This is where that part of the graph came in. It appears to go up from 1 to 3 and from 6 to 18. So that went up $12 for 2 hours. Then it went up from 18 to 36, it went up $18. And from 3 to 6 over the course of 3 hours, well, guess what? 18 divided by 3, 12 divided by 6. Both of those will be 6 hours, $6 per hour with no starting number. There's no extra deposit or fee. So the cost for Water's Edge rafts can be represented in equation form as 6 times h hours plus 0. Let's take a look at Ryan's rafts. Now this appears to go up $2.50 for each hour, but that surely looks like there is some starting value that is not 15. In fact, if we went backwards, we could go back 1 hour and we could then go down, take off that first 225, and you will find a fee, maybe it's a deposit, whatever they call it, of $12.75. So the equation for Ryan's rafts is going to be $2.25 times h hours plus $12.75 fee or deposit, whatever that might be. Now remember, our ultimate goal, which company do we want to choose for 9 hours? So what we can do is rewrite these equations and substitute 9 into each. 6 times 9 plus 0, 54. 225 times 9, it's going to be about $20, but don't forget the $12.75 starting value, the fee. Wow. So if I'm going to answer, I would personally choose Ryan's rafts. If they both are 9 hours, Ryan's rafts would cost $33, while Water's Edge would charge $54 for the same amount of time. If you want to go the extra mile, you could even say that would be $21 more. So, if you wish, you can carry on to question 4, which basically says, what would be the advantages of an equation and the disadvantages of an equation? Some folks prefer graphs. Some folks prefer tables. Some folks prefer words. I would encourage you to be strong in all 4 of those. Now go ahead, rate yourself. Put yes, put question, put no. Bring some questions along to class. Advantages and disadvantages. That's a question you could ask about all things in life. Carry into your homework, ladies and gents, numbers 9 through 17. And don't forget a little extra time on Khan Academy because you know what's coming up tomorrow, the 18th. All right, folks, that's all I got for you. Take care. Let's grow.